Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alman bin Kamsani. Today I'm going to present my final year project 1 under supervisor Dr. Muhammad Nazali bin Haji Muhammad. Today I'm going to present unmanned aerial vehicle or UAVs controlled by leap motion sensor via hand gesture. Let's go with introduction. Okay, drones or unmanned aerial vehicles is an aircraft that requires no pilot on board. Today it's been widely used in the filming, military and education purposes. However, leap motion sensor is an electronic device that is used to sense the human gesture using infrared scanner and camera. Leap motion has been developed from 2014 and until today. The technology of leap motion is expanding and has been applied in many ways such as medical training, education, and much more. Okay, this is my problem statement. The problem statement is the remote control nowadays have a limit control, and it's only used to perform a specific task. And also, the drones require no controller to perform a flight, which means nowadays when we buy the drones, they also have a controller, which is we need to bring the two things together. Okay, next, to provide more stable controlling system using leap motion sensor. And final one is to create an interface that can view the hand gesture and allocate the drones. My objective is to identify all possible hand gesture movement that can be detected by leap motion sensor with certain movement of a drone, and also to develop a system that can directly connect the drone by using only the software in a computer with leap motion sensor, and also to provide a more stable controlling system using leap motion sensor and interact with drone directly. And finally, to create an interface that can view the hand gesture and allocate the drones. My scope is the area of the project only consists of area where the drone can be controlled using leap motion via Wi-Fi coverage. The drone also will be controlled using a leap motion sensor, which is using the hand gesture control for giving the instruction. And several tests will be conducted in order to evaluate the performance of the developed system. Literature review. This is my comparison. My comparison is I compare it with my project and the data body mission interface for drone control through voice and gesture. This project consists of two input, which is sensor tile. Both are using sensor tile, which is one is used for voice capturing and the second one is for the gesture capturing, and it uses processor Raspberry Pi 3 and MoVDS processor of MoVDS. The drone is also a custom-made drone, which is using RC controller. This research paper contains no GUI, and my project using leap motion sensor, and my processor is a computer, and my drone is DJI Tello EDU, and it also have a GUI. The comparison that can be seen is that data-driven body machine interface for drone control through voice and gesture is using sensor tile for voice recognition and hand gesture recognition. However, the voice recognition have its limit due to the voice sample that can be inserted to the Raspberry Pi, which used for controlling method. The hand gesture using sensor tile also limit due to its position and hand detection, which is if you using a sensor tile, it's only used for the palm position. So the finger does not affect on controlling the movement. So it's limit on the palm only. It's only used for rolling gesture, yaw, and pitch gesture. However, my project using leap motion sensor, which is can access more than 3 gesture, which is the gesture is also have a yaw, pitch, and rolling, and also it can recreate a new gesture by using the software itself, but it's a bit difficult. And also leap motion can sense fingers, bones, and the yaw in the hand palm position, so we can create more controlling system using the leap motion sensor. For next comparison, I compare to the another paper, which is Drone.io, a gestural and visual interface for human drone interaction. For the input of the paper, using depth camera and pico projector, the processor is using iPod Touch A8 processor, and the drone is DJI Phantom 2. They also have a GUI. My area is using leap motion sensor, computer and DJI Tello, and it also provides the GUI. Okay, the comparison, we can see that the advantages of the drone I/O. The drones can interact with the user with a simple task using projector and depth camera, which is the paper said that they are using it for the interaction between the drones and the user using the projector. By user can interact it with using a hand and the movement of the feet, and it also can fly around 20 minutes since it's using DJI Phantom. The disadvantages compared to my project is the drones both cannot flying and moving around, which is it used to interact to the user, but it's not suitable for the moving and flying around, like moving forward and reverse, and then fly around away. And another disadvantages is the interaction is not really effective if the sunlight is really bright in the daily light. The interaction become blurry and cannot be seen. Compared to my project, the advantage is the drone can be used as a flight system where the drones can be controlled. It is a small drone that can fit in small places compared to the DJI Phantom, and also can provide a variable hand gesture controlling system. And the disadvantages is since I'm using a DJI Tello, which is have low battery life with maximum of 13-minute maximum flight time, and the UI can be used only to guide the movement of the drones only and can't be used as a game interaction compared to the drone I/O. Okay, that's all from my literature review comparison. Okay, let's go on to the methodology. Okay, this is my methodology. My project system method, which is it start from the start, and then the system initialize the computer, leap motion, and the drone, and then we put the hand gesture on top of the leap motion sensor for recognition, and then hand tracking. The leap motion start to track the hand gesture, and if it is detect and it goes to the computer process the hand gesture and then execute for drone control, and the drone will move around depending on my programming, my hand gesture programming. And that's all for the project flowchart. This is my block diagram, which is my input is using a hand gesture and then processed using a computer, which is the computer using software of Visual Studio 2019, and the output is the Tello EDU drone output. The connection between the laptop and the Tello EDU drone is via Wi-Fi, and the connection between the hand gesture to the process is using leap motion sensor and via USB. Okay, I'm going to proceed with my preliminary result. My result only consists of the connection of the leap motion sensor and to the computer only. For the drones, I cannot be applied yet since the COVID-19 problem. The posting is a bit late for the drones. So the drones is I only receive it 1 week before my presentation right now. So I cannot discover anything yet for the connection. So I'm going to proceed with my preliminary result. Okay, as you can see, this is my coding. The most stop is used for calling file function for the libraries and so on. And it consists of the gesture, which is a fingers and bones and the state names for the leap motion recognition. Okay, let's proceed with the coding execution. Okay, as you can see, when the coding execution, it display the hands, fingers, tools, and the gesture. So when I put my hand here, it start going to messy, where I need to pause, and then it can be seen that it show everything, which is the ring ID, middle ID, and it hard to explain. So I'm gonna explain it one by one by disable of a certain things. Okay, now I'm going to proceed with the basic print, which is it will show the frame ID, timestamp, number of hands, number of fingers, tool, and gesture. Okay, for make it the video easy, so I'm going to use a visualizer. So it can be assumed that my hand is on the link motion sensor when I move it. So let's run my coding. Okay, you can see as it can be seen that the number of hands is 0, fingers and tools and gesture. So when I put my hand, it show the number of hands is 1, finger 5, tools and gesture is 0. Okay, so if I put my two hands, it will show the number of hand is 2 and the fingers is 10 with 2 0 and gesture of 0. Okay, now I'm gonna proceed with the frame hands. As you can see, the frame hands will print the hand type, hand ID, and hand palm position. It also prints the pitch of direction, normal roll direction, and the yaw direction. It also print the arm direction, arm wrist position, and arm elbow position. With also the finger names, finger ID, finger length, and finger width, and also the bone name, bone prev joint, bone next joint, and bone direction. Okay, let's try the coding. As you can see, the coding is already initialized, but it show nothing if we didn't put any hand. If I put a hand, if I put my hand, and then it will show the full output. Even if I move, it show everything. Okay, let's see what it tells here. It show the distal start and distal end, direction, immediate start, coordinate, and end coordinate, and also the direction coordinate, proximal start and proximal end in direction. And here we can see also that it show the pitch condition, the pitch value, and the roll value and the yaw value, and also it show the direction, start, and end. Okay. The yaw value, if it's getting positive, then the yaw position is in the is in the right, and if it in the negative value, and it show the left position. Roll, when it comes to negative, then the rotation of the hand is counterclockwise, and if it's positive, is a clockwise. And the pitch value going to be negative if the hands is going to the bottom, and the pitch position will get the positive value when the hand is in up position. Okay, now I'm going to move to the frame gesture, which is circle gesture. The circle gesture going to show the clockwise or counterclockwise position depend on my hand position, and also going to show the circle ID, circle state, radius, swept angle, and the clockwiseness. The clockwise depend on the clockwise or counterclockwise. Okay, let's start the coding. Okay, as you can see, when I put my hand, it show the ID, the state, the swept angle, and counterclockwise. However, when I start rotate, it show the clockwise position when I rotate. Okay, and then if I counterclockwise, it show the position is in the counterclockwise. Okay, now I'm gonna proceed with the swipe gesture. Okay, let's execute the code. Okay, the code is initialized, and now I'm gonna put my hand and swipe, and it show, as can be seen, that it show the direction, the position, and the swipe ID, the coordinate of the position, the coordinate of the direction, and the speed of my moving hand. Okay, now I'm going to proceed with my last gesture, which is the key type gesture. The screen type gesture cannot be used since there are no screen can be suitable for showing the gesture. Okay, I'm going to proceed with my key type gesture, and now I'm going to run the coding. As you can see, when I type it, it will show display. It will display the type function, which is it's going to show the key type ID, the state and position coordinate, and the direction of the coordinate. Okay, the movement the gesture that I discussed earlier, such as the counterclockwise, the yaw and pitch position, I'm gonna set it as the movement of the drones, but I've not decided yet what is the movement that's suitable. I'm on planning that the type function is used to on the drone, and the yaw position is used for the drone for moving right and left, and the pitch pitch position gonna forward and backward position for the drones. I think that's all for my preliminary result. That's all from me. Thank you very much.